In this video, we're going to look at worked answers to each of these 6 questions. If you want to have a go at these before looking at the worked answers, pause the video now. In this question, we're told that calcium carbonate will decompose to form calcium oxide and carbon dioxide when it's heated. We need to explain if the backwards reaction will be exothermic or endothermic. We'll start answering this by annotating the question. We're told that we're heating this, so it means the forwards reaction must have some energy going in. So explain means we need to give a reason why. And we're looking at what happens in this case in the backwards reaction. So the question tells us that we heat the forwards reaction. When we heat something, that means we're putting energy in to make it happen. So if we need to put energy in, that means it's an endothermic process. And you can remember this by if energy goes in, or if the energy enters, it's going to be endothermic. The overall energy is going to increase. With these kinds of questions, it's always a good idea to write out the equation again and label on what the forwards and backwards reactions are. So we've said that because we're heating the forwards reaction, it must be endothermic, so we've added that on with an arrow. We know that the energy changes are always opposite of each other, so if the forwards reaction is endothermic, the reverse reaction must be exothermic. So we can now put this together in our final answer. So we start off by saying the forwards reaction requires heating, therefore the forwards reaction must be endothermic. This means that the backwards reaction must be exothermic. In this question, we've been given an equilibrium, and we're told that the forward reaction is endothermic. If the pressure of this equilibrium was increased, what would happen to the equilibrium yield of chlorine? Explain your reasoning. So let's start by breaking down the question. So the key things is that we're looking at pressure, if it is increased, on the yield of chlorine. Now, even though the question tells us that the forward reaction is endothermic, this question has nothing to do with temperature, so we don't need to use that. That's additional information. The question asks us to explain, so we need to give a reason why. The first thing we should do to answer this question is to write out the equation again, so we can see clearly what's happening. We can then have a go at annotating this. We know that the pressure depends on the number of gas molecules on each side, so we'll start by annotating that onto our equation. There is 1 gas molecule on the left-hand side, and 2 gas molecules on the right-hand side, the molecule of ICl and the molecule of Cl2. The side with the fewest number of gas molecules will have the lowest pressure, and the side with the highest pressure. So this means that the left-hand side is going to have the lowest pressure, because it's got 1 mole of gas, and the right-hand side is going to have the highest pressure, because it's got 2 molecules of gas. And as a reminder, we are increasing the temperature, and we're wanting to see what effect this has on the yield of chlorine. So we would start our answer by saying that if the pressure is increased, the system is going to shift to decrease that pressure. The system's going to want to do the opposite. If we're increasing it, it's going to want to decrease it. Because we've annotated our equation, we know that the left side has got low pressure. So if we increase the pressure, we're going to shift to the left side to decrease that pressure. We need to explain why we're doing this. And we're doing this because the left has the fewest number of molecules of gas, therefore the lowest pressure. The question asks us though, what will happen to the yield of chlorine? So if we're shifting equilibrium to the left-hand side, we're going to make more of whatever is on the left and less of whatever is on the right. Therefore, we're going to make less chlorine. So we would say that the yield of chlorine will decrease. Remember, the yield means how much of it will we make. We're looking at the same equation, but this time the question is asking us what would happen if the temperature was increased. So let's break down the question again. This time we're looking if the temperature was increased, what would happen to the yield of chlorine? Again, we're explaining why, so we need to give a reason. This time, since we're talking about the change that the temperature will have, it is relevant that the forwards reaction is endothermic. The next thing we should do is write out an equation again. Now we've written our equation out, we can annotate it with the information from the question. So we know that the forwards reaction is endothermic, so we should draw this on our equation. We know that if the forwards reaction is endothermic, the reverse reaction must be the opposite, which will be exothermic. So we'll add this on as well. Now we've added on which way is endo and which way is exo, it's always a good idea to add on as well if these reactions get hot or cold, because it'll help you work out what to do if the temperature is increased or decreased. So endothermic reactions get cold and exothermic reactions get hot. And finally, as a reminder, we are increasing the temperature and we want to see what effect this has on the yield of chlorine. So if the temperature is increased, the system will shift to decrease the temperature. It will do the opposite. Now, in order to decrease the temperature, it's going to shift right, go in the direction of the forwards reaction. And that makes sense, because in order to decrease the temperature, the reaction will want to get colder, and we know endothermic reactions make it go cold, so if we increase the temperature, it will do the opposite by going in the cold or the endothermic direction. Now, when we're explaining our answer, we have to give it in terms of energy. So we would say that it goes to the right because the forwards reaction is endothermic, and this means it takes energy in. Because if we're increasing the temperature, we're actually just adding extra energy. So the system wants a way to take in that extra energy, and we know that endothermic reactions will take in energy. Although the hot-cold way is another way you can work it out. Finally, the question asks us what effect this will have on the yield of chlorine. So chlorine is on the right-hand side. If we are shifting to the right, we're going to make more of everything on the right-hand side. Therefore, the yield of chlorine will increase. In this question, we're once again looking at what will happen if the pressure is increased. What effect will that have on the yield of hydrogen? And we need to explain our reasoning. So as before, the key points in this question is that the pressure is increasing. What is the effect, given a reason why, on the yield of hydrogen? We're told that the energy change is -42, but again, this question is about pressure, so that is just extra information. We don't need to use it for this question. We should start off by drawing out the equation. Now we've written the equation, remembering that the side with the most molecules will have the highest pressure, and the side with the least number of molecules will have the lowest pressure. We can add this onto our equation. In this case, however, there are two molecules of gas on each side. There's the carbon monoxide molecule and the water molecule on the left-hand side, and the carbon dioxide and the hydrogen molecule on the right-hand side. So there are two molecules of gas on both sides. Now remember, since the pressure is determined by the number of molecules of gas on each side, and we have the same number of molecules of gas on each side, this means the pressures can be the same on each side. So we'll see how we can include this in our final answer. So we'll start off by saying just that. If we increase the pressure, the number of molecules of gas is the same on both sides. Therefore, the pressure is going to be equal. This means that the equilibrium can't shift to change the pressure, because no matter which side it moved to, it would still have the same pressure. So if the equilibrium's not going to shift, therefore there's going to be no change in the yield of hydrogen. We've got the same equation again, but this time we're looking at what would happen to the yield of hydrogen if the temperature was decreased. So the key points in this question is that if the temperature was decreased, what would happen to the yield of hydrogen? We need to explain our reasoning, which means we need to give a reason why. This time, since we're looking at temperature, the energy change of the reaction is relevant. As the energy change is negative, this means energy is exiting the reaction. Therefore, this will be an exothermic process in the forwards direction. As before, we will write out the equation first. Now we need to annotate it with information about the exothermic and the endothermic directions. We know from the question that the forwards reaction is going to be exothermic, so we'll add that on first. We know that if the forwards reaction is exothermic, the backwards reaction must be endothermic. And to help us answer this question, we can now add on that exothermic will get hot and endothermic will get cold. Remember, when you're giving your final answer for this, you need to include the reasons why in terms of energy, but this is a good way to check you're doing it correctly. And as a final reminder, we're looking at what would happen if the temperature was decreased and the effect that would have on the yield of hydrogen. So if the temperature was decreased, the system would want to shift to increase the temperature. It would want to do the opposite. In this case, it would shift to the right to increase the temperature, because we know from our labels that the right is exothermic, therefore gets hot. So if we make it colder, the system wants to do the opposite, making it get hotter. We have to give our explanation in terms of energy though, so we would say that going to the right is exothermic. If we are decreasing temperature, we are taking energy away from the system, so the system will want something which will release energy, and we know in an exothermic process, energy exits the reaction, so that energy is going from the reaction to the system, replacing the lost energy. So you'll shift to the right, because that's exothermic, and that process will release energy. So what effect will this have on the yield of hydrogen? Well, hydrogen is on the right-hand side. If we are shifting to the right, we're going to make more of everything on the right, therefore the yield of hydrogen will increase. In this question, we're told that yellow chromate ions will react with hydrogen ions to form orange dichromate ions. If acid is added to this equilibrium mixture, will it become more yellow or orange? Explain your reasoning. So there's a lot to take in this question. We've now got to link the colours to the different chemicals being used. We've got to know what happens if we add more acid and what that will do to the colours. This is an explain question, so we need to give a reason why the solution would go one colour or the other colour. Once we've written out our equation, it would be useful to add on what colours these chemicals are. So the question tells us that the chromate ions will be yellow and the dichromate ions will be orange. So we've added that on to help us and to stop us getting mixed up later on. The question also says if we add acid to the mixture, what will happen? Well, we need to think back our work from a previous topic and know that acid means H plus ions. And we can see we've got H plus ions in the question. So this is just making it a little bit trickier. So rather than saying if H plus is added to the mixture, it's asked us if acid was added instead. So just a little bit further to test your understanding. So if the concentration of H plus increases, the system is going to want to shift to decrease the H plus concentration. Well, the H plus is on the left-hand side, and there's no H plus on the right-hand side. So if we want to reduce the amount of H plus in the solution, we're going to have to move to the side where there's no H plus. Therefore, we're going to shift to the right. If we're shifting to the right, we're going to make more of everything on the right-hand side, which means we're going to increase the yield of these dichromate ions. So if we're increasing the amount of dichromate ions, and the dichromate ions are orange, that means the mixture's going to become more orange. Finally, for the last question, we've got the same set of equations again, with the same coloured chemicals, but this time we're asked what is going to happen if we add alkali to the equilibrium mixture instead of acid. So let's pick out the key bits of the question once again. So as before, we've identified which chemicals are which colour, we're adding an alkali, and we need to know what would happen to the colour. This is an explain question again, so we need to give a reason why this change is happening. The next thing to do is label the equation again with what colours each of the chemicals are. So just as we did for the first part of this question, we're saying that the chromate ions are yellow and the dichromate ions are orange. Adding these now will help us not get mixed up later on. Again, this question requires knowledge from our previous topic. We need to know that acids are H+ ions and alkalis are OH- ions. We also need to know that when an acid reacts with an alkali, it forms water. And we can put all these bits of information together to help us answer the question. So if we add alkali to the mixture, the alkali which we add is going to react with the acid in our mixture, and it's going to form water. So this will have the effect of both decreasing the amount of acid in the mixture, because it's reacting with the alkali, and increasing the amount of water in the mixture, because when the acid reacts with the alkali, it's going to form some more water. So the first thing we need to do is just say what happens when we add the alkali to the mixture. Now, this means the equilibrium is going to shift to the left for two reasons. The equilibrium wants to decrease the amount of water, because we've effectively increased it, and it wants to increase the amount of hydrogen ions, H+, because we're decreasing those by adding the alkali. Now, shifting to the left will solve both those problems. If we shift to the left, we're going to make more of the acid and less of the water, reversing the change we explained in the first part. So we want to decrease the water because we've made some more water. We want to increase the amount of H+, because we've decreased the amount of H+. Therefore, shifting to the left does both of these things. Since we've shifted to the left, we're making more of everything on the left-hand side and less of everything on the right-hand side. We've said that the chemical on the left-hand side is yellow. Therefore, if we're shifting to the left, we're going to increase the yield of the chromate ions. Therefore, the mixture will go more yellow.